Awesome. Cool. All right, so today we'll see how Edna can disguise and reveal your data to put you back in control of it. To illustrate what I mean, let's take Twitter. So you might have considered leaving at some point, like many others, and you were faced with a tricky choice. Like some high-profile users, you could have deleted your account, even though you may have wanted to come back at some point. In doing so, you prevent Twitter from accessing your data, but you also permanently lose your millions of followers. Or you could have kept your account up, like some others who said they would leave. But unfortunately, this lets Twitter retain access to your data, including private messages and search history. Beyond just Twitter, users want more control over their data. For example, on dating apps, users come and go, and they want their sensitive data protected while they're not using the application. And users on Reddit or Instagram went to the effort to manually create and manage throwaways. For those who grew up without social media, throwaways and finstas dissociate data that users want to separate from their main identifying account. For example, I might make a post about medical questions in a throwaway. These examples point to the need for more than just account deletion, to time out the data of inactive accounts and dissociate data into anonymous throwaways. And removing this data is not enough. Users should be able to revive their accounts or manage their throwaways. We capture this in-between state of user data, where users are not quite gone because they can return, but they're also not quite there because the application cannot access their private data, with a new abstraction of disguised data. Between the time data is disguised and the time the user later reveals it, the data is left inaccessible to the application, and placeholder data remains to keep the application structure intact. For example, if a user removes a post with comments on it, a placeholder post will maintain the comment thread structure. So it's clear that users want more fine-grained and flexible controls over their data. So why don't developers actually implement what users want? Well, first, there was no clear definition of this in-between state of data. But even with disguised data as an explicit goal, developers still face several challenges. First, the last thing any developer wants to do is break their application. And disguising can be particularly error-prone. For example, let's take a user here, Bob, who has a shared message with Helen, and some public post with comments on it. So say Bob wants to disguise their account. Disguising would remove Bob's account entry, but have to deal with maintaining referential integrity by introducing placeholder data. Developers must make sure to carefully remove the correct data and introduce the correct placeholders. Disguised data also introduces challenges of composition. So one composition challenge is that disguised data can be disguised again. For example, say a developer wants to support both a throwaway disguise and a temporary account removal disguise. Then, if we have Bob here who owns one post, Bob can create a throwaway so their post is dissociated from their account and reassociated with some placeholder anonymous panda. And then Bob may later want to remove their account and all their data, even the throwaways data. So no data is left in the application database. To support this, the developer must determine which posts of which throwaway users belong to Bob in order to remove them. However, this seems impossible. The whole point of a throwaway disguise is that the application has no information that lets it determine links between users and their throwaways. Furthermore, we want Bob to be able to reveal their data, and because data can be disguised multiple times, it can also be revealed multiple times, and not necessarily in the same order. If you've developed a web application, you can imagine how challenging these semantics would be to implement correctly. And that's where Edna comes in. So Edna is a system that automates disguising and revealing and makes developers' lives easier. Today we'll discuss not just Edna, but also how developers use Edna by writing disguise specifications with 3 primitives, the techniques that Edna uses to realize disguising and revealing, namely pseudo principles as placeholder data, reveal credentials which allow users to reveal data, speaks for and diff records as encrypted disguised data, and speaks for chains, which allow disguises to compose. And we'll talk about the first 3 today. Finally, we'll present an evaluation of Edna with 3 real-world applications. So let's dive first into how developers use Edna. The developer links Edna as a library in their application and adds hooks to invoke Edna's API. They also write specifications for each disguise that they want to support, for example, throwaways. This is a one-off setup, so the developer doesn't continuously need to think about disguising and revealing. A developer writes a disguise specification using 3 primitives: remove data, modify it, or decorrelate it from the owning user, where the data is chosen by a provided predicate. Developers only need to think about disguises on the level of these disguise specifications, and these primitives allow developers to express a wide range of disguises. The challenges of maintaining referential integrity or composing these disguises are then left to Edna, and we'll see how Edna handles this later. So as an example disguise specification, say the developer wants to support clients creating throwaways. The developer simply has to specify the table, which is posts, the type of primitive operation, decorrelate, which will dissociate data from the owner, and a predicate on the tag, which will be instantiated to be the topic to throw away when the client invokes the hook. So we've seen how developers use Edna. Let's take a look at what clients do. Edna introduces reveal credentials to allow users to reveal their data. Credentials can be a private key of a client's key pair, but for usability, Edna also supports users' passwords or backup tokens as credentials. Clients register accounts with Edna by providing their public key, usually done when they create an account with the application. So we've seen what developers and clients do, but now let's actually dive into the techniques that Edna uses to disguise and reveal data. Pseudo-principles serve as Edna's way of implementing placeholder data. They let users dissociate data and create throwaways without breaking the application. In this example, Bob instantiates the throwaways disguise spec to decorrelate all Kung Fu posts from their account. This causes Edna to automatically generate pseudo-principles, in this case, the anonymous panda, to maintain referential integrity. Pseudo-principles can be decorrelated at different granularities. For example, every data object can recorrelate to a unique pseudo-principle, or groups of objects, for example, all comments in the same thread, can be decorrelated to one pseudo-principle to preserve reply structure. When Edna performs a disguise, Edna creates disguise data, which it stores in the application database. Disguise data is made of 2 types of encrypted records. So, for example, when Edna creates Bob's throwaway account, Edna stores a speaks for record that proves that Bob can speak for or act as the anonymous panda. Bob can later use this record to act as the anonymous panda to edit their Kung Fu post. Edna also stores a diff record, which stores the actual data change. So in this case, it's rewriting a foreign key of the Kung Fu post to refer to anonymous panda. As we'll see, this will let Bob reclaim their Kung Fu post. Both of these records are locked via Bob's public key. When Bob actually wants to reveal disguised data, that's where their reveal credentials come in. So if Bob wants to reclaim ownership of their Kung Fu posts, Bob will give their reveal credential to the application in Edna to unlock their disguised data. Edna can then use the information stored in their records to restore ownership of the Kung Fu post to Bob and remove their pseudo-principle. Once the revealing is over, Edna will forget Bob's disguised data and credentials. However, we note that Edna cannot just naively reveal data, as doing so may overwrite existing application updates or violate referential integrity. So Edna performs consistency checks for these scenarios and only reveals if the checks pass. Speaks for records and reveal credentials also allow Edna to compose disguises. So recall if Bob wanted to remove their account after creating a throwaway, Edna would have to discover Bob's dissociated data in order to remove it. Edna supports this composition of disguises by allowing clients to also provide their reveal credential when they invoke a disguise. Edna can then unlock Bob's disguised data, and in particular, Bob's speaks for record, and use this to find and remove all of Bob's data, including Kung Fu posts. When removing this data, Edna generates diff records for the remove account disguise, which will allow Bob to later reveal their account if they wish. Finally, Edna forgets the reveal credential that Bob provided. So Edna also supports composition of out-of-order reveals with speaks for chains and composition of disguises over shared data. To see how Edna does this, please check out the paper. So now knowing Edna's design, we can ask what guarantees Edna provides. Edna assumes a threat model in which developers are well-intentioned and write specifications that capture the correct data to disguise. We also assume that clients keep their credentials safe, and we put attacks that leverage external data copies such as screenshots out of scope. Under this threat model, Edna provides confidentiality of data between the time the data is disguised and the time the user reveals it, and it does so via encryption. Neither the application nor Edna has the keys to decrypt the disguised data, thus providing GDPR-compliant crypto shredding of data. However, Edna does leak the existence of pseudo-principals or metadata left in the application database, such as the size of disguised data, because Edna's design chooses to sacrifice some security for usability. For example, decorrelation is key to enabling fine-grained and flexible disguises, but it does leave placeholder data available to attackers. Edna's prototype is written in Rust and works with relational databases. We use a password-based key derivation function in conjunction with Shamir secret sharing to allow users to use their passwords or a backup token in case they forget their passwords as reveal credentials, and you can see the paper for more details on how we achieved this. Using our implementation, we next evaluated whether Edna actually works in practice. So first, we asked whether Edna can work with existing applications. To answer this question, we'll focus on Lobsters, which is a link sharing discussion forum. With Edna, Lobsters can support all three of the data controls we mentioned, throwaways, data timeout, and account removal, with the option to reveal or edit the disguised data created from each. This is done without changing Lobster's database structure and simply adds JSON specs and application hooks that instantiate these specifications and invoke Edna's API. As you can see, they're quite straightforward to write, and in total, added less than 0.5% to the Lobster's codebase. And even then, most of these changes were to add UI elements to support these hooks. We also implemented 2 disguising transformations, each in HotCrap and WebSubmit, a homework submission site, and we found similar results. We next asked whether Edna's disguise and reveal operations affect normal application performance. Edna adds no direct work to existing application operations, but because Edna does consume resources, of course there may be indirect impacts due to contention. So to test these impacts, we evaluate both low and high load scenarios on the x-axis with application operations throughput on the y. And as a baseline, we run a typical Lobsters client workload without Edna. We then run the same workload with Edna constantly disguising and revealing a randomly selected user. So here we see that both under a low and high load, disguising an average user has a low impact from 4 to 7%. And then we also evaluate the worst case scenario with Edna constantly disguising and revealing the most expensive user with the most data. So this user has 1% of all the data of 16,000 users. So you can imagine just how much this user uses Lobsters. Under high load, we find a moderate impact up to 17% drop in throughput. This shows the upper bound on Edna's performance impacts when Edna runs large disguising and revealing transactions continuously, which we imagine to be an unusual scenario in practice. We note that disguises themselves have acceptable performance. On average, they'll take milliseconds, and worst case, with lots of data, they'll take a couple seconds. We also explored how difficult disguising would be without Edna, and how Edna could be combined with encrypted databases, and you can see our paper for more details. Of course, there's existing work on deleting or securing data in web applications, and these lines of work also help move towards better data protections. Data deletion frameworks such as Delph or K9DB focus on correct data removal, but the removed data is permanently gone and cannot be restored. Policy enforcement systems such as CAPLA or Blockade prevent unauthorized users from accessing data, but they don't protect the data from server compromise or from authorized users. And encrypted databases such as CryptDB and Mylar protect against database server compromise, but they leave the data still accessible to authorized users. Although Edna targets the separate problem of disguised data, Edna can be combined with these systems. For example, our paper combines Edna with CryptDB to protect undisguised data. So today, I've discussed how users lack sufficient controls over their data, and how we can meet users' needs with disguised data. Edna transforms data between disguised and revealed using the techniques that we discussed, and moves us towards an internet that better meets users' privacy needs, where applications allow users to selectively remove, and later reveal data at will. And the best part is that Edna is practical to deploy with existing applications today, and if you want to do so, you can find Edna at the link below. I'd like to thank all my collaborators for helping to make Edna a reality, and thank you all for listening, and I'm happy to take questions.
Questions?
Hi, Suyesh Gupta from UC Berkeley. Very cool work, I'll say. My question is, can this not be exploited by a malicious party? In the sense, you're expecting the developer or the organization to store the data. Now, a malicious party can come and actually keep on creating a lot of accounts, and then it will keep on disguising, as you're saying. So at the end, you're expecting the organization, like Twitter, to keep all the records for the whole period of time, which in general it could have deleted now. And now because of that, there's a lot of bogus data which is being lying there. So what's the solution?
Yeah, that's a really good point. So Edna currently doesn't distinguish between, say, like spam accounts and normal user accounts. And there is this notion of users should be able to return and reveal their data at any point in time. But we imagine that these type of accounts are already problematic for web applications today. And sure, like, it will consume more storage for these web applications. We can imagine a garbage collection scenario that collects disguised data after 5 years or some timeout whenever the application developer doesn't want to deal with it. But given that storage is not a huge cost for these web applications today, and they already have to deal with these accounts on a much more malicious level with like spam and kind of when it's like them posting fake news and things like this, I think it's a problem that they'll have to deal with on the application side.
Thank you.
Hi, Mingyu from SJTU, a very cool work. I'm wondering if suppose a dialog window and user B quote the data belonging to A in his context. If A wants to remove his accounts, will the data will be also disguised in B's dialog?
Sorry, I didn't...
Like B quote the data belonging to A, and A wants to disguise his data. But since B quote his data,
I see. So like embedded text. Yeah, so if there's no explicit link from the embedded text to user A, then the types of ownership that, like user ownership that Edna can dissociate this data from will not be, I guess, present. It has to be integrated into the structure of the schema of the application. But if the developer does make this an explicit ownership link, so if I refer to, like if I'm user B and I embed user A's data in my post, and that creates a link from user A to my post that's explicit in the database schema, then the developer would be able to dissociate this from user A's identity. There are more sophisticated, like in K9DB or even in Delph, ownership tracking of data, and that's something that definitely could be added to Edna.
Okay, so basically it's the responsibility of the developers to specify the ownership, or not?
Yes, that's part of the specification. We could definitely imagine, like most of the applications we looked at, these ownership links could be automatically derived as they are foreign key relationships. But these more implicit relationships would definitely have to be indicated by the developer.
Okay, thanks.
Yeah. Definitely.
Stefan Suri of Microsoft, very cool work. I actually had a question, sort of, you've worked on this area for a while. If I were to start a new social network on which I actually want to support disguised data from the ground up, would you start by using Edna on Or would you sort of start with a clean slate design?
I see. So are you asking whether we would need Edna at all, or whether we would just design the web application?
So I think one of the very nice properties here is that Edna works with existing applications.
Yeah.
But if I don't need that,
So if we weren't bound by the
exactly,
limitations.
if I would start something new from the ground up, would you use Edna, or would you sort of start with a new design?
I believe that a lot of the fundamental aspects of web applications, like relational databases or shared data and server-side processing, those are aspects that make disguised states of data difficult. And so even with building an application from the ground up, I mean, we can imagine radical new inventions of database design and things like that, but I believe a system like Edna would still be helpful. There might be things that we can make easier, for example, making ownership links very explicit.
Thank you.
Okay, let's thank Lillian again for the great talk.